Hello guys, welcome back to my channel. This is your homeboy Sir Chris. In today's video, we shall be deradicalizing this radical expression. So let's go through the solution together. I have parentheses open, the cube root of root 5 plus 2 minus the cube root of root 5 minus 2, parentheses closed, all to the 2014. Since we are not going to use a calculator, we shall do or make do with some pertinent algebraic identities or formulas. But before then, we shall make substitutions. So I'll say, let S be the cube root of root 5 plus 2. So if I take the cube on both sides here, I will denest this radical. I'm going to be having S cubed equal to root 5 plus 2. I will label this equation 1. Similarly, I'll say let y equal to the cube root of root 5 minus 2. If I also take the cube on both sides, I shall be having y cubed equal to root 5 minus 2. I will label this equation 2. Then the next thing is to subtract equation 2 from equation 1. From the left-hand side, we are going to be having s cubed minus y cubed. So we have s cubed minus y cubed. Then on the right-hand side of both equations, we have root 5 minus root 5. They will eliminate each other. That's 0. We then have 2 minus 2. And that's going to give us 4. So I shall label this equation 3. Then from the cube of difference, we have s minus y whole cubed. So upon expansion, either using repeated multiplication of s minus y 3 times, or binomial theorem, or the Pascal triangle, we are going to be having s cubed minus 3s squared y plus 3sy squared minus y cubed. So our task is to isolate s cubed minus y cubed, because we already have it as equation number 3. So I can start to say s minus y cubed equal to s cubed minus y cubed minus 3s squared y plus 3sy squared. So if I make s cubed minus y cubed the subject, that's the killer punch. S cubed minus y cubed equal to s minus y whole cubed plus 3s squared y minus 3sy squared. Now, I already know that s cubed minus y cubed is equal to 4 from equation 3. So I need to look for the value of xy. But before we do that, we can factorize something out from these two guys, 3s squared y and 3sy squared. So the common factor there is 3sy. So we shall have s cubed minus y cubed equal to s minus y whole cubed plus, like I said, we factor out 3sy. 3sy divides into 3s squared y. We are going to be having x minus 3sy divided into 3sy squared. We shall be having y. So we know s cubed minus y cubed, which is equal to 4 from equation 3. So we need to find the value of x multiplied y. So we record that s is the cube root of root 5 plus 2. So y is the cube root of root 5 minus 2. So S multiply y is going to give us the cube root. Then I will multiply these two guys inside this radical. That will be rad 5 plus 2 multiply rad 5 minus 2. If you observe carefully, this is a difference of two squares. A squared minus B squared, that gives us A minus B multiply A plus B. Whichever one comes first here, it doesn't really matter. So we use difference of two square formulas. We can then resolve these two guys. So S multiply Y will then give us cube root. So using this formula, this is going to give us rad 5 whole squared minus 2 squared. So rad 5 whole squared is rad 5 multiply rad 5, which is 5. So this is going to give us the cube root of 5. Then 2 squared, that's 4. So we are going to be having the cube root of 1, which is equal to 1. Now that I know the value of S multiply Y, which is 1, then I know S cubed minus Y cubed equal to 4 from equation 3, then I can then substitute into this formula here, okay, into this guy here, which I shall label equation star. And if we do that, we shall reduce the complexity of this problem. 4, which is S cubed minus Y cubed, then we are going to be having S minus Y whole cubed plus, we already know the value of SY, which is 1, 3 multiply 1, then multiply S minus Y. So if we tidy this up, we are going to be having S minus Y whole cubed plus 3 multiply S minus Y, everything equal to 4. This is actually a depressed cubic equation. So if you are smart, you can actually solve this without a substitution. But for the sake of our audience, we'll say, let U equal to S minus Y. So if we say U is equal to S minus Y cubed becomes U cubed. 3 multiply S minus Y, that becomes 3U, because U is S minus Y. So this is also going to be equal to 4. So this is a depressed cubic equation, like I said. So if I rearrange this, we have U cubed plus 3U minus 4, everything equal to 0. Now, because this cubic equation is easily factorable, there is no need for me to use the trie-error or synthetic division. And also by guessing and checking, you can see that U equal to 1 is actually a root of this equation. So now, if we are to factorize, in place of 3U, I will replace it with minus U plus 4U. That does not really alter anything. Minus U plus 4U, that's 3U. So we shall have U cubed minus U plus 4U minus 4, everything equal to 0. So we shall factorize this by grouping. So for the first group, you can see that U is actually common. So if I factor out U here, I will use U to divide U cubed, which will give us U squared. Minus, I will use U to divide U, which is 1. In the second pair or group, 4 is common. If I factor out 4, use 4 to divide 4U, we have U. Then minus, I will use 4 to divide 4, that's 1. So everything equal to 0. If you check well, in this first parenthesis, U squared minus 1. Because 1 is a square number, this is also a difference of two squares. And we should also make do with the difference of two squares formula, which we are familiar with. So U squared minus 1 can be written as u squared minus 1 squared. So this can be written as, okay, sorry, that will be written u plus 1 multiply u minus 1. It doesn't really matter which one comes first, the positive or negative. So we shall replace it in our equation. We are then going to be having u multiply u plus 1 multiply u minus 1 plus, okay, that will be plus 4 into u minus 1, everything equal to 0. So these three guys and these two guys, they have u minus 1 in common. So we can factor it out. So if I factor out u minus 1, I'll open a bracket. U minus 1 divides into these three guys. Then we have u multiply u plus 1 left. U minus 1 divides into these two guys. We are going to be having 4 left. So everything equal to 0. So if we distribute this inner parenthesis, we shall have u minus 1 multiply u squared, u multiply u squared, u multiply 1, that's u, then plus 4. Everything equal to 0. Now, from the zero product property, we have u minus 1 equal to 0, or, okay, let me remove the parentheses, or u squared plus u plus 4 equal to 0. So if we add 1 to both sides here, we are going to be having u equal to 1. Like I said, by guessing and checking, which is also a problem-solving technique, u is actually equal to 1 from the depressed cubic equation. Then our next task is to see what happens to these quadratics. We know that the discriminant d is b squared minus 4ac. And from these quadratics, a is 1, b is 1, and c is 4. So discriminant will then be 1 squared minus 4 times 1 times 4. And I guess it's going to be negative. So this quadratics is going to generate complex roots. D is going to become 1 minus 16, which is negative 15. So because the discriminant is less than 0, it implies that we are going to reject the quadratics because it's going to generate complex solutions. So our only true solution is u equal to 1. Now we made a substitution along the line that u is equal to s minus y. Now, our main problem we are trying to simplify or evaluate is the cube root of rad 5 plus 2 minus the cube root of rad 5 minus 2, all to the power of 2014. So you can see that from our substitution, s is equal to the cube root of rad 5 plus 2, y is equal to the cube root of rad 5 minus 2, and s minus y is equal to 1. Hence, our solution is going to be 1 to the power of 2014, which equal to 1. So this is the solution to this radical expression. So guys, thanks for watching. If you enjoyed this video and you derive value, please ensure you subscribe and follow us for more. See you next time and stay blessed.